Okay, digit problems are a little unique, and to be able to do digit problems, you have to understand some basics about the way our number system works, which you take for granted. So let's forget about this question for a second, and let's just talk about the way numbers work. If I write this, right, and I say, what number is that? You say it's 38. You don't say it's 38. You say it's 38. And the reason why is because this is the ones place, right? This is the tens place, right? And if I had another number, this would be 238, right? This would be the hundreds place, right? Now, what does this mean? How do I figure out the value of this number? I'm really taking 2 times 100, and I'm adding to it 3 times, 10. And I'm adding to that 8 times 1, right? So I get 200, 30, and 8. I add them up, I get 238. That's really what I'm doing. These numbers aren't 2, 3, 8 next to each other. It's 238 because this is the hundreds, this is the tens, this is the ones. So likewise, if I had a number that I was representing with variables like x, y, z, and I told you it was a 3-digit number, this would not be mathematically represented as x, y, z, because mathematically that would mean I'm multiplying x times y times z. But just like over here, I was not multiplying 2 times 3 times 8. I was using these tens, hundreds places. So this would be hundreds, this would be tens, and this would be ones. So the value of x, y, z, when I talk about the number x, y, z, what I really mean is x times 100 added to y times 10 added to z times 1, right? And I'd get 100x plus 10y plus z. So when I'm talking about a 3-digit number like this, that I don't know the digits for, when I say the 3-digit number, mathematically I don't mean x, y, z. I mean 100x plus 10y plus z. I mean the value of the number, the value, right? Just like over here on the when I wrote this on the board, when I referred to this number, you said 238. You added them all up kind of in your head, and you said 238. You didn't say 2 times 3 times 8, right? Just like over here, when I say this number, I don't mean x times y times z. I mean the value of it, which is 100x plus 10y plus z. Okay, so let's use this knowledge to solve a problem. So, in this question, I'm going to read from the question. It says, the sum of the digits of a 2-digit number. So in my head, I'm just going to write down x, y over here, and this is the 2-digit number I'm looking for. So x is the tens digit, and y is the ones digit. I'm just going to write it up there so I remember what I'm looking for. Okay, so the sum of the digits of this number is 11. So one of the digits is x, one of the digits is y. The sum of those would be x plus y equals 11. Okay. Now it says, if we interchange the digits, okay, so now they're saying if instead of writing it as xy, if I write it as yx, okay, then the new number formed is 45 less than the original. Now, this is the new number formed, right? However, when I say the new number, I don't mean y times x. I mean 10y plus x, because y is in the tens position, x is in the ones position. So when I say the new number formed is 45 less than the original, I mean the value of the new number, and I also mean the value of the original number. Whenever I refer to the number, I mean the value of it, and we obtain the value by multiplying the digit by whatever place it's in. So in the top one, x is in the tens, y is in the ones. In the bottom, y is in the tens, x is in the ones. So now let's read the sentence. If we interchange the digits, the new number is. So the new number I'm talking about is this one, the value of the new number. So 10y plus x is, right, 45 less than the original. Now, when I talk about the original number, I'm talking about the value of the original. So 10x plus y, and then 45 less than that, minus 45. So here's my two equations, right? Now, I highly recommend that you simplify the bottom equation before you move on. So let's simplify the bottom equation, right? So I have, I can get my x's and y's over to the left. So this is x plus 10y, right? I'm just rearranging it, putting it in order a little, equals 10x plus y minus 45. So first I can subtract 10x from both sides, and I get negative 9x plus 10y equals y minus 45. And then I can subtract y, so I get negative 9x minus, or plus 9y, right? 10y minus 1y is 9y, equals negative 45. So there's this equation, and then again, I have the original equation right up here, this one, what color I can make it this. This is the original, and I'm going to write it down here so that I have my system. So here's my system with the bottom equation simplified. All right, so now I have to be able to solve this. I think it's easiest just looking at this if I divide both sides of the top equation by 9, right? So let's do that. I get negative x plus y equals negative 45 divided by 9 is negative 5, and the bottom equation is x plus y equals 11, right? And we can use elimination. Negative x plus x is 0, y plus y is 2y, 11 and negative 5 is 6, so y equals 3. And then I can substitute into this equation right here. X plus y equals 11, so x plus y is 3 equals 11, x equals 8. So look at what I have here. I have x equals 8 and y equals 3. And the number they're asking us for is the original number. This one is the original number, xy. So the original number is x is 8, y is 3. So the original number is 83. Now let's see if it works. The sum of the digits is 11. 8 and 3 is 11. Perfect. Now, if we interchange the digits, so again, I'm just checking now. If we interchange the digits, right, we get 38. The new number is 45 less than the original. So 38, if I add 45 to this, I get 83. So it is 45 less. So this number is correct. Okay? Now, again, the tricky part of these problems, when they refer to the number, they're talking about the value of the number. The way you find the value of the number is you figure out which, if it's a 2-digit number and it's xy, it's 10x plus y. If it's a 3-digit number, xyz, it's 100x plus 10y plus 1z, right? The tens units, or the units, the tens, the hundreds place, the thousands, the 10,000s, right? Now, most likely you'll only deal with 2 or 3-digit numbers, so you don't have to worry about going too far, but it's based on the position that the digit is in.